This section is going to be full of lectures and assignments around persistent data. And first, we're going to discuss the problems of persistent data and how that even became a problem in the first place. So key concepts there that you need to understand are the idea of immutable infrastructure and the idea around containers being naturally ephemeral in design. So we'll cover those in the first lecture. And then we'll dive into data volumes and how those solve some of our problems around persistent data. And then we'll also dig into bind mounts and how that solves different problems with persistent data. And then we'll end up this section with a couple of assignments around how to preserve database data while replacing containers for databases, and then also around actually mounting code into a container from the host while you're editing it so that you can run that code inside the container live. And requirements for this first lecture are just understanding how to run containers and the container and image concepts we've discussed so far.
Until now, you've only worried about what's needed to run a container, not the unique data that might be created once the container's running. Containers are meant to be immutable and ephemeral. Now, those are just fancy buzzwords for unchanging and temporary or disposable. But the idea here is that we can just throw away a container and create a new one from an image, right? So then we're not talking about an actual limitation of containers, but more of a design goal or a best practice. This is the idea of immutable infrastructure, where we don't change things once they're running. And if a config change needs to happen, or maybe the container version upgrade needs to happen, then we redeploy a whole new container. This gives us huge benefits in reliability and consistency and making changes reproducible, but there's a trade-off. So what about the unique data that your app will produce? Those databases or key value stores or anything else that your app spits out into a file. Ideally, the container shouldn't contain your unique data mixed in with the application binaries. This is known as separation of concerns, and Docker actually gives us a big benefit here. We can update our application by recreating a new container with an updated version of our app, and ideally, our unique data is still where it needs to be and was preserved for us while our container was recycled. Now, in case you haven't noticed so far, the containers that we've been using by default were persistent. So any changes in them actually were kept across restarts and reboots until we removed the container. Just because we stopped a container or restarted the host doesn't mean the container's file changes go away. It's only when we remove the container that its UFS layer goes away, but we want to be able to do that at will. So this problem of unique data is known in the industry as persistent data. And until containers, we didn't really have a name for that because, well, most things we built were persistent. Like, those old servers that have been running that old app for 5 or 10 years or longer. Everything was persistent by default. So now in the new world of containers and application autoscaling, persistent data creates a unique problem. So Docker has two solutions to this problem known as data volumes and bind mounts. So Docker volumes are a configuration option for a container that creates a special location outside of that container's union file system to store unique data. This preserves it across container removals and allows us to attach it to whatever container we want. And the container just sees it like a local file path. Then there's bind mounts, which are simply us sharing or mounting a host directory or file into a container. And again, it'll just look like a local file path or a directory path to the container. It won't actually know that it's coming from the host. All right, volumes seem pretty simple up front, but there's actually a lot to it. So the first way you can tell a container that it needs to worry about a volume is in a Docker file. And let's go check some of those out. So I'm just gonna do what I do a lot, and I'm gonna search for MySQL. So this is how I learned so much about Docker files and how to use them correctly. Is the official repositories have really sound defaults and best practices built into them. So I'm gonna go over here to the MySQL one. I'm just gonna click on the latest Docker file here. And I bet you because it's a database, it's probably got a volume command in it. Yep, there we go. So this is the default location of the MySQL databases. And this image is programmed in a way to tell Docker that when we start a new container from it, to actually create a new volume location and assign it to this directory in the container, which means any files that we put in there in the container will outlive the container until we manually delete the volume. And that's something we should point out here, is that volumes need manual deletion. You can't clean them up just by removing a container. They're an extra step. And that's just for insurance, really, because the whole point of a volume command is to say that this data is particularly important, at least much more important than the container itself. So if we do a Docker pull on MySQL, and then I do a Docker image inspect on MySQL, we don't get to see the Docker file because the Docker file isn't actually part of the image metadata, but you'll notice in this config area that it specified that volume there. So I can always tell that the config that came from the Docker file when it was built assigned a volume to that path. So let's run a container from it. So Docker container run -d --name MySQL. And if you remember from earlier, the MySQL one's a little special. It now requires an environment variable before it'll work. So it's MySQL _allow _empty _password. Okay. We should see our MySQL running. And if we do a Docker container inspect MySQL, we should see the same thing where it tells us in the config that there's a volume here. We can also see it up here under mounts. And what this is this is actually the running container getting its own unique location on the host to store that data, and then it's in the background mapped or mounted to that location in the container, so that the location in the container actually just thinks it's writing to /var/lib/MySQL. But in this case, we can see that the data is actually living in that location on the host. So let's do a Docker volume ls, and we can see we have now one volume. And now we notice that it's got that unique ID that we'll never know what the heck that goes to, right? So let's do an inspect on that. Now you don't have to type the whole thing out. You can just type the first couple of characters and hit tab to complete it, but you'll get that similar information about the volume itself. Now, if you're actually doing this on a Linux machine, you could navigate to that location on your hard drive and see the data. There'll actually be some databases there. But if you're on a Mac or Windows, remember that Docker for Windows and Docker for Mac are actually doing a little bit in the background that's hidden from us, where it's actually creating a Linux VM. And so this data is technically inside that Linux VM. So you're not going to be able to go to that path on your Windows or Mac machine and see the data. It's actually inside that VM. But we'll see in a little bit with mounted volumes how we can get around that limitation as well. So by looking at this, you notice that it's not very user-friendly in terms of telling us what's in it or what this volume is assigned to. We can see from the container's perspective what volume it's using, but we can't see from the volume perspective what it's connected to, right? And if I were just to hit the up arrow and let's see, create a MySQL 2, so that's now created another MySQL server running in the background. And if I do another Docker volume ls, you'll see two of them. You start to see the problem, right? There's no real easy way here to tell one from the other. And if we just to prove a point, do a Docker container stop MySQL and a Docker container stop MySQL 2. And we do a Docker container ls, we'll not see any containers running. If we do an ls-a, we get to see them all and notice that they're stopped. And if we do a Docker volume ls, you notice we still have the two volumes. Now, if I do a Docker container rm MySQL and then MySQL 2, because I can actually do both of those in one command, it'll remove both my containers. And if I now do a Docker volume ls, my volumes are still there. My data is still safe. So we've solved one problem. The databases outlive the executable. So how do we make this a little more user-friendly? Well, that's where named volumes come in and the ability for us to specify things on the Docker run command. So if I hit the up arrow a couple of times till I get to the Docker container run, it doesn't really matter which one you're going to run again. In this case, we're going to actually throw in a -v command. And a -v allows us to specify either a new volume that we want to create for this container that's about to run, or it allows us two other options. One of them here is to create a named volume. So if I just did -v and then the var lib mysql, that would do the same thing as what our volume command in the Docker file did. So we don't really need to do that here. But what we can do is I can put a name in front of it with a colon. That's known as a named volume. And when I do that, and then do a docker volume ls, you'll see that my new container is using a new volume, and it's using a friendly name. So if we do a docker volume inspect on that MySQL, you'll see that this is easier to use here. And if I deleted my container again, and we have to put in a -f because it's still running, and then I run another one, and this time I'll give it a different name, and then we do another docker volume ls, you'll see that it looks like we haven't created a new volume. It's still using the same volume. So let's do a docker container inspect on the MySQL 3. And then what we'll see up here is, yes, this is what was configured, but what are we running? This is our mounts up here. So we'll see here that not only is the name friendlier, but it actually changed the source location to be a little friendlier as well. So for me, a little tip here is that when I am running for days or weeks at a time, a particular database in a particular container that I need to keep using over and over, and I don't want a blank database server, I'll end up creating my containers this way and naming them for the project so that I know what that volume's for and that it needs to stick around. Now, one last thing here. Why would you want to do docker volume create? So if we can create them from a docker container run command at runtime, and we can create them by specifying them in the Docker file, there's only a few cases where you'd want to create it ahead of time. And you can actually figure that out pretty quickly by using the help command, because here is the only way that we can actually specify a different driver. Remember that plugin stuff I'm going to talk about later? And then any driver options that we want to use the -o on, and then if we want to put labels on it, which we'll also talk about later in the production section. So sometimes in special cases, you do need to create the Docker volume ahead of time, but usually for your local development purposes, just specifying in the Docker file or at the run command is fine.
In this lecture, we're going to talk about bind mounting and persistent data in those mounts. And the requirements are really that you just know about container management, how to run containers. So let's jump in.
So let's talk about bind mounts, and they're actually pretty cool. When I first learned about them, it sort of gave me an aha of how I could use Docker easily for local development. So really, a bind mount is just a mapping of the host files or directories into a container file or directory. And you can do just that. You can either specify a directory or just a single file. In the background, it's basically just having the two locations point to the same physical locations on disk. Again, this actually skips the UFS like the other volumes do, so that it's not going to wipe out your host location when you delete the container. And if there are any files in the container that you map the host files to, the host files win. Now, it doesn't actually delete the files in the container that it overwrote, because it's not really overwriting anything in the container. It's just there while the bind mount exists. So the minute you don't need the bind mount anymore and you rerun the container without it, you would actually see the underlying data that was there before. And because bind mounts are usually host specific, they need specific data to be on the hard drive of the host in order to work. You can't specify them in a Docker file. You have to use them at runtime when you use the docker container run command. And you can see the format here. It's really the -v that we used before, only on the left side of the colon, we're actually putting in a full path rather than just a name. And the way that Docker actually can tell the difference between a named volume like we did a while ago and the bind mount is the bind mount starts with a /. And on Windows, you'll notice that it's a 2 // and then the drive letter and then your path. So as long as you have the left, colon, and right sides, you can really map anything you want from the host into the container. And you can also specify things like read-only. Now, where this really comes to shine is with development and running services inside your container that are accessing files you're using on your host or changing. So let's do that with Nginx. So if you go to the root of our repository for this course, and then we go into the Dockerfile sample2 directory. Now, we were in here earlier, and if you remember, there's two files. And this is for Nginx, right? So if we look at the Docker file real quick, it's pretty simple. It's just specifying a working directory and then copying an index file into that directory. Now, there's no volumes here. A bind mount doesn't require a volume to work, although one could certainly be there, but the host always wins, remember? So when we're doing a Docker container run, then we do a -d, let's name it Nginx. Let's give it the port 8080 like before. And then we're going to give it the volume this time. And I need to tell it my current working directory is going to be actually mounted into that working directory in the container. Because my index file is here in this folder, I want it to be in the container so I can edit it here and it is seen live in the container. So it'll make sense in a second. Here's a quick little tip. Instead of me having to figure out my whole path and typing the whole thing in, you can use pwd here like so, which is a shell shortcut that says print out the working directory and replace this command with that path. And then we're just going to use the same working directory from the Docker file there. And then we're going to specify the Nginx image. Now, what I'm going to do real quick is I'm actually going to open up another terminal window so we can do two things at once. And you don't really need to do this. Basically, we're just going to edit the file on our host, and then I'm going to be in the container and see what's happening. So just to make sure it's working, let's go to localhost. Okay, so this isn't the default Nginx HTML file. And we used the regular Nginx image. We didn't actually use the custom one from this directory. We just used a stock image. And to prove that point, we can actually do that same exact command again, but take out the -v, and I'll run it on port 8080 instead, and I'll call this one Nginx 2. And if I go over to my browser and go to localhost 8080, that's the default Nginx index.html file. This one is the custom one that we have living in this directory. So already we can see that it mapped it correctly. And if I open up another tab here and get a command line in the container, and then go to that directory, you'll notice that we can actually see the Docker file because we mapped the whole directory. So if over on the left, if we actually made a new file, and I can just use the Linux touch command here to create a new file, and then over on the right, oops, just keep forgetting that, ls-al, and you'll see that new file. So hopefully you understand that what's going on here, that both these locations are the same location. And if I echoed something in to that test.me file, and then there you go. Our Nginx is able to see the changes because it's just a normal file path in the container, and those files are on the host. And if I was to delete them in the container, they would be deleted on the host because it is the same file. So this is when I usually get a developer to get mind thinking about all their development environments that they have that are this complicated setup. Maybe they're using Vagrant or some other manual method of setting up their perfect environment. And they can start to see how this could make that so much simpler. Because I didn't have to do any complicated setup on my Mac. I just ran a container. I used the -v command with the mount. And now my code on my host can be edited on my host. And I really never need to go into the shell of the container. Usually you can just run the container and look at its logs to see if there's any errors while you're coding. And of course, this is a simple example with Nginx. But later on, we're actually going to have specific examples of different development environments for local development in containers.